Welcome to this college algebra training video all about regression. This video is another video about finding the function equation. However, when you do your regression, you use all the points that you're given, not just 2 or 3. Wow! This is the process that we used before when we had 2 or 3 points that we were using. A couple problems with this is, first of all, we had exact data. This only works if you have exact data. By that I mean when you graph it, it lines up perfectly on a pretty graph. But life isn't like that, right? We have lots of different data points, some even for the same x value, some for the same y value. We got to figure out what to do with those kind of graphs. And it only works when you have a square matrix. So last time we were dealing with 3 by 3, a 3 by 3 matrix in our equation. And we had like a 3 by 1 and so on. But it only works if you have a square in your equation. And when you use all the data points, that is definitely not going to be a square unless it's like 200 by 200. Probably not going to happen. So we need a different way to deal with this. Part of this process that we use today is going to be the same. Like these steps are going to be included in our process. But we got to figure out what to do with all those points. Before we do, we need to talk about a few more matrix basics. So when you see a matrix, the rows are written first, like 3 by 3, and then the columns. So if it's a 5 by 3 matrix, it has 5 rows and 3 columns. So keep that in mind. In order to multiply two matrices, you need to have this be true. The number of columns in the first matrix must equal the number of rows in the second matrix. So let me give you an example. If I have an A by B matrix, whatever those numbers are, and a C by D matrix, then these two numbers have to be the same, B equals C. And the resulting matrix, whatever you get as a result, is going to be A by D. So, for example, going back to our 5 by 3, if we multiply that by a 3 by 7 matrix, then our 3's match, that's good, and our resulting matrix would be a 5 by 7. So if we have, say, like a 13 by 3, 13 rows and 3 columns, and we want to multiply to get a result of 3 by 3, we got to figure out what to multiply that by. So we already know that the columns will have to match the rows here. So we know that we're going to have a 13. And our end result will be a 3 by 3. So we need this to be a 3 by 13. In order for us to multiply them, these match, and then 3 by 3 will be our end result. If we have a transpose, then we can definitely make a square matrix. What a transpose is when you take a matrix and just reverse the columns and rows. So if we're looking at this 3 by 2, it's going to become a 2 by 3. And what was a column here now becomes a row in the transpose. Right? And what was a column in the second column is now the second row. So if we multiply these two, we'd have a 3 by 2 and a 2 by 3. Those match, and we'd end up with 3 by 3. Every time you multiply a matrix by its transpose, you get a square matrix, which, remember, we need to do regression. So here's our new process for finding the functions using all the points. That's what regression means. Okay, but still, we'll graph it. I didn't put that in the process, but we'll graph it and try to figure out what kind of function it is. And you're going to have a big, long matrix that's not a square in your equation. Okay? And then we're going to transpose that matrix, multiply them to get a square matrix, which you can then take the inverse of. This is why we needed the square. You can only find the inverse of a square matrix. Those matrix rules. So we needed the square. After we multiply by the transpose, we have it. And then the rest is going to be very familiar from the last video. Right, you're going to multiply by the inverse, find the inverse and multiply by it, and then you'll have your answers. It's going to work. Let's try it out. To Excel! Oops, switch There we go. Here we are in Excel. Put the process up there for us. If we need it. First, let's decide what kind of function this is. By the way, this is data that is about Old Faithful. The guys are in Yellowstone National Park. And in the assignment that you're doing for this video, you're actually going to do a lot more points about the same context. So it has like 200 points on it. We're just going to do 20 for the videos. You can have fun with those 200 points later. It's going to be great. Let's graph it. Let's see what this looks like. So I'm going to insert a chart. A scatter plot. Okay. So we could do some different things, different kinds of polynomials, but it looks actually pretty linear. And given the context of the Old Faithful eruptions, so what the x values are how long the eruption lasts, and the y values are the time until the next eruption. So that makes sense that it would be linear because those are minutes to minutes, and they would relate in that way. So we're going to try out linear, and you'll try out linear on your assignment as well, unless you really want to do it polynomial. You can try that out. We're going to do mx plus b. Okay, so that's going to be our equation, and I'm going to write it backwards just like we've done before. Mx, I'll go ahead and hide that, plus b, and leave room for the other matrix, equals, and then we'll put our y values over here. So we make a linear equation. All right, so in our first column, we're going to have all the x values because we're trying to find, remember, m and b. And so this is m times whatever x is. So I'm going to go ahead and put in these x values here. And we will drag that down. So we have all the x values all the way to 5.5. Okay, and then remember in front of the b, just like with the c in the other video, there's just a 1 in front of it. So we just have 1s all the way down. And we'll fill those in. Okay, and yours, again, your equation is going to be a lot longer than this one because you're going to use more points than me. And we'll go ahead and make our matrix a box. Don't have to do that. I just like to. All right, and then that's going to multiply by a little matrix here where we put our variables, our unknowns, which are the coefficients, m and b. Those multiply to equal. The y values are going to come over here, so we're going to have another long equation with lots of rows, or a long matrix with lots of rows. All our y values here. We'll drag that down till we have them all the way to 89. Yep, and we'll go ahead and put a border. Okay, so this is what I meant by the long matrix equation, right? Definitely no squares. So we're going to then transpose it to try to get that square. I'm just going to do that over here on the right. And Excel is always coming in clutch with the cool formulas. It'll just transpose it for you. You don't have to cut and paste the rows and make them columns. It'll just transpose it. So we'll highlight this array. So this right now is a 20 by 2. Our transpose should be a 2 by 20. And there it is. So beautiful. If I scroll over, you can see the whole thing. Again, yours will be a lot longer. All right, step 3, multiply both sides of the matrix equation by the transpose. So we're going to use our mult again. So fun to say. Okay, again, it's very important which matrix you put first. So we're going to transpose first. All the way, scroll all the way over. Put my comma in. Back over here. I always forget the new hashtag thing. That's cool. Shows the whole array. All right. Oh, a square. So we multiplied a 20 by 2, oh sorry, 2 by 20 by a 20 by 2, and we got a 2 by 2. That's why the transpose had to be first, or else we would have a 20 by 20. That'd be huge. All right, everything else is the same on this side of the equation anyway. Go ahead. Oh, let's make this little matrix box. And that's so equal. But what you do to one side of an equation, you have to do to the other side. So we have to multiply the transpose first on the right side with all those y values. So we're going to mult again. And we're going to highlight that transpose. root of 5.5, comma, our y values. So we're multiplying a 2 by 20 by a 20 by 1, so our result will be a 2 by 1 when the 20s matches. And there, all right, so we got that side of the equation. Step 4, we have now a square matrix. Now from here, it's the same as what we did in the last video on using matrices in Excel. So we're going to now find the inverse of the square matrix. There we go. Beautiful inverse. And remember, once we multiply these, we should, on the left side, get the identity matrix. It's always an important thing to look for. If you don't, something went wrong. So we will now, step 5, multiply by the inverse. So inverse first, just like with the transpose, it's got to come first. On both sides of the equation. Oh, no, that's not 0. It's 0. It's just being weird. Yeah, if I change this to that, yep, there you go, it's 0. Oops, wrong way. Yeah, sometimes that'll happen and your students may freak out, but it's just close enough to 0. That rounding happened up here, so that happened. So we have our identity matrix. Phew, scared there for a minute. Alrighty. All right, okay. Beautiful, M and B, and now we have to do the same thing over here. We're going to multiply a 2 by 2, the inverse, mult this by a 2 by 1, and our result will be a 2 by 1. And there are our answers, but we are not done. Remember, this is just the value. Whoa, it went away. Oh no. Oh, there, it's back. Okay. Remember, these are just the values for M and B. We have to make our equation. So remember, it's a linear equation. So we have y equals M is 9.49. Let's say 9.94. 9.94. X plus B, which is 37.715. Ta-da! When you do this, you'll get some different answers for this part because you're going to use some more points, and so it'll be a different equation, but it'll be a little bit pretty close to this. And one way you can check is we can go back to our graph. Start a graph again. Scatter plot. Okay. And then we can add a trend line. And let's do it linear one so it matches. And let's show the equation on the graph. And it is the same equation. Excel actually uses regression, just like we just did, to find that trend line. You can also, in Excel, show the R squared, if you're familiar with statistics. That is just a measurement of how accurate the trend line is. The least squared is regression. There it is. Okay, let's play R squared. The closer that R squared is to positive 1, then the better it is. So that's a pretty accurate linear equation. Pretty cool. You can check it that way. All right, that is regression. Now you can find functions for even things that are not exact data, and that's pretty cool. A lot of students will get confused with some of these steps. You're gonna help them a lot. Thank you for helping them. Good luck.